Over the centuries, many important ancient texts and inscriptions have been damaged to the point of illegibility. Can AI help historians to decipher broken or incomplete texts, making history more certain? The advent of history was marked by the invention of writing, which is critical to our understanding of past civilizations and the world we live in today. The Sumerians began writing on clay tablets more than 5,000 years ago. Humans have been at it ever since. The ancient Greeks were writing on stone, pottery, and metal more than 2,500 years ago. They chronicled everything from leases and laws to calendars and oracles, providing a rich picture of Mediterranean life. Regrettably, the picture is incomplete. Many surviving writings have been damaged or moved from their original sites over the centuries. Contemporary dating techniques, such as radiocarbon dating, cannot be performed on these materials, making them difficult to place in the timeline. In an article published recently in Nature, DeepMind presented Ithaca, an AI platform developed in collaboration with several universities. Ithaca is the first deep neural network that can reconstruct damaged inscriptions missing text, identify their original location, and help establish the date they were made. Named after the Greek island in Homer's Odyssey, Ithaca expands on Pythia, DeepMind's earlier textual restoration system. Tests demonstrate that Ithaca can restore damaged texts with 62% accuracy, identify their original location with 70% accuracy, and date texts to within 30 years of their ground truth date ranges. Already historians have used the tool to reassess pivotal moments in Greek history. Ithaca is trained using the largest digital dataset of Greek inscription from the Packard Humanities Institute. Words are frequently used to train natural language processing models because the order in which they appear in phrases and the relationships between them provide additional context and meaning. For instance, "can't see the forest for the trees" conveys more meaning than each individual character or word. Yet many of the inscriptions that historians wish to analyze in connection with Ithaca are damaged and frequently missing large sections of text. To guarantee that Ithaca's model remained functional when confronted with one of these, DeepMind trained it with both words and individual characters as inputs. To maximize Ithaca's utility as a research tool, DeepMind developed several visual aids to help historians clearly interpret Ithaca's findings. Restoration hypotheses. Ithaca generates a number of prediction hypotheses for the text restoration task from which historians can select based on their expertise. Geographical attribution. Ithaca displays its uncertainty by providing historians with a probability distribution covering all conceivable outcomes rather than a single output. As a result, it yields probabilities for 84 distinct ancient regions, indicating its confidence level. It then visualizes these findings on a map in order to shed light on probable underlying geographical links throughout the ancient globe. Chronological attribution. When Ithaca dates a text, it generates a dispersion of estimated dates spanning the centuries from 800 BCE to 800 CE. This lets historians see the model's confidence for certain date ranges, which may provide insightful historical information. Saliency maps. Ithaca employs a technique often used in computer vision to identify which input sequences contribute the most to a prediction in order to communicate the results to historians. The output highlights the words in various color intensities that contributed to Ithaca's missing text, location, and date predictions. DeepMind's tests demonstrate greatly how Ithaca's design choices and visualization tools improve researchers' interpretation of data. Working alone to recover old writings, experts generally achieve about 25% accuracy. Ithaca by itself achieves 62% accuracy in repairing damaged texts. When historians and Ithaca team up, their combined performance improves to 72%. This demonstrates the power of human-machine collaboration to promote historical interpretation, establish relative dates for historical events, and even contribute to modern methodological debates. For instance, historians currently are divided on the date of a series of major Athenian decrees issued during the lives of notable personalities such as Socrates and Pericles. The decrees were long assumed to have been written before 445 BCE, but fresh evidence reveals they were written around 420 BCE. Although this may appear to be a minor distinction, these decrees are critical to our knowledge of classical Athens' political history. To put Ithaca's predictions to the test, it was retrained on a dataset that didn't include the dated inscriptions. These texts were then submitted for study. Amazingly, Ithaca's average estimated date for the decrees is 421 BCE, coinciding with the most recent dating advances and demonstrating how machine learning may contribute to arguments about one of Greek history's most critical episodes. While ancient Greece is important to our understanding of the Mediterranean world, it is simply one aspect of a global panorama of civilizations. This is why DeepMind is working on Ithaca versions trained on other ancient languages as well. And historians may already utilize datasets in the existing architecture to research other ancient writing systems, ranging from Akkadian to Demotic, from Hebrew to Mayan. This work demonstrates how models like Ithaca may harness the cooperative potential of AI and historians, transforming the way we study and write about one of the most critical periods in human civilization. Explore the interactive version of Ithaca yourself by following the links below. Like, follow, subscribe, and catch us next time to see how you, plus science, can help save the world.